Welcome to this deep dive. Today we're tackling a really interesting academic paper titled Historian Lets AI Be a Historian, a KG-powered multi-agent system for accurate biography generation.
Historian, huh? Catchy name.
It is. And what immediately stood out to us is the ambition here. Creating an AI that can produce not just text, but accurate and stylistically appropriate historical biographies.
Yeah.
That's a high bar.
It really is. I mean, we're moving beyond simple summarization, into the realm of historical narrative. And that demands a level of precision of understanding that's traditionally been, well, the domain of human historians.
Right.
And while large language models, LLMs, they've shown incredible progress in generating text, we know they often fall short when it comes to factual accuracy, especially sticking to specific styles, like, say, classical Chinese historical writing.
Exactly. So this research coming out of Zijian University and Huawei, it directly addresses these limitations with this system, a historian. The core idea seems to be combining a knowledge graph. You can think of it as a highly structured database of historical facts with a retrieval-augmented generation process, RG, and then layering on top of that a whole team of AI agents whose job is basically to stop the main AI from, well, making stuff up.
Right, like built-in fact checkers working alongside it as it writes. It's like giving the AI access to this really organized historical record and a team watching its back.
Yeah. And the results they're reporting are pretty remarkable. Compared to other advanced AI models, a historian showed almost a fourfold increase in factual accuracy.
Fourfold. Wow.
Yeah, and a big drop, 47.6% in the rate of hallucinated information.
Yeah.
You know, the AI just confidently stating things that aren't true. They tested this on a real data set of historical figures, the Jinshi dataset.
Okay, so that's significant.
Definitely. So our goal today is to really unpack the architecture of AI historians, understand its place in, the ongoing evolution of AI in historical research, and maybe even explore some interesting possibilities for the future.
Sounds good. Let's dive in.
Okay, so the paper lays out their system. You can kind of think about it in stages, even if they don't explicitly label it that way. At its heart, I think, is this recognition that generating a good historical biography isn't just summarizing documents. It's a really specialized form of it with very specific demands.
And Huawei's involvement is interesting, too. They mention collaborations with museums, which kind of highlights a real-world need for AI that can actually work reliably with historical data. It's not just theoretical.
Totally. What's fascinating is how they've broken down the unique challenges. It's not enough to just pull out facts. The AI needs the right tone, the right style.
Yeah, imagine trying to get an AI trained on, like, modern web text to write like a historian from centuries ago. It's tough.
Right. And it also needs to ensure absolute correctness of every detail and synthesize information that might be scattered across lots of different documents.
A historian seems to tackle this with a pretty comprehensive end-to-end system. They talk about an offline phase where it builds this knowledge graph from texts and also fine-tunes its underlying LLM.
And then there's the online phase, where it actually generates the biography. It uses the knowledge graph to find relevant info, and then deploys this team of multi-agents to generate and verify as it goes.
Okay, let's start with that KG-powered REG retrieval-augmented generation. So RDRE generally means the AI looks up information first, then uses that to generate its answer, right?
Yeah, basically.
A historian's approach starts with building this knowledge graph offline. And this happens in 3 key steps. The first one is called training-free pattern-enhanced text chunking.
Okay, training-free, that sounds good.
It is. It's quite clever. The researchers notice that historical documents often have these consistent ways of introducing people. Like, you might see a name, then their formal style name, maybe a nickname.
Ah, recurring structures.
Exactly. So they use just a few examples in context, learning to show the AI these patterns. And the AI then learns to break down long texts into meaningful chunks based on these patterns. No need for a huge, specially labeled training data set for this part. It learns from the way the documents themselves are organized.
So it's leveraging the inherent structure of the historical writing itself. Okay, that makes sense. Then what?
Then comes regex-driven relation extraction. So instead of just asking the LLM, hey, pull out the facts, they prompt it to generate a search pattern, a regular expression or regex that's tailored to each chunk of text.
Like for that name style nickname pattern we mentioned.
Precisely. The AI might generate a regex that looks specifically for that sequence, and then this regex is used to automatically pull out triplets of information like head entity, the person, relation, styled as tail entity, the style name. It's a more targeted way to get structured data.
And if the regex doesn't quite work for a chunk,
They have a fallback. If the regex fails, they just ask the LLM to directly extract the triplet information from that chunk. It's a backup plan.
Got it. So it's a more controlled extraction process.
Yeah, and arguably more interpretable than just letting the LLM summarize freely. Finally, they take all these extracted triplets, all these relationships, and build their knowledge graph. The historical figures are the nodes, the relationships are the edges, like was styled as or was nicknamed.
And crucially, they link everything back to the source text, right?
Exactly. Each node, each connection is linked back to the specific original text chunk it came from. That provides clear provenance for every piece of information in the graph.
Okay, so now you have this structured knowledge base. When a historian needs to write a biography for someone specific,
It queries the graph, finds the entry for that person, retrieves the relevant text chunks connected to that node. That's its source material. But interestingly, it also looks at the neighboring nodes in the graph.
people connected to the main person.
Yeah, to get broader context, something a simpler retrieval system might miss. It helps build a richer picture.
Okay, that covers the retrieval part. Now let's get into the error-aware generation with multi-agents. This is where the real-time fact-checking happens.
Right. But even before the generation starts online, they do some smart pre-training or fine-tuning of the underlying language model offline. They recognize that, there isn't a massive amount of perfectly formatted, stylistically perfect historical biography data just lying around.
Right, specialized data is often scarce.
So they use a two-step fine-tuning process. First is data augmentation enhanced supervised fine-tuning, or SFT. Since they don't have mountains of ideal training data, they get creative.
How so?
They shuffle key biographical facts within the source texts they do have. And they even introduce distractor documents, basically, irrelevant information into the training mix.
To make the AI better at filtering out noise and focusing on what's actually relevant and accurate.
Exactly. It's like giving it practice drills in information discernment.
Makes sense. And the second step?
That's stylistic preference optimization, or style PO. They use a technique called SIMPO here. Essentially, they train the model with pairs of examples. They show it positive examples like well-written biographies by human experts in classical Chinese.
The gold standard.
Right. And then they show it negative examples, maybe modern Chinese translations that have slight inaccuracies or just don't have that specific historical style.
So it learns not just what's factually right, but also what sounds right for a historical biography.
Precisely. It helps align the AI's output with both factual fidelity and the desired historical style.
Okay, so the AI is prepped factually robust, stylistically aware. Now, online generation time. Deploy the agents.
Exactly. 7 specialized AI agents jump into action. First up is the verifier.
Okay.
It takes the biography as it's being generated sentence by sentence, or really atomic fact by atomic fact. They define an atomic fact as a short sentence with basically one piece of biographical info.
Simple units.
Yeah. For each atomic fact, the verifier checks it against the reference material retrieved from the knowledge graph. It uses something called token-level Jacquard similarity, first to filter out any reference documents that aren't actually relevant to that specific fact, and then it prompts the underlying LLM to find specific supporting evidence within the remaining relevant documents.
And this happens for every single sentence. Wow. Continuous quality control.
Pretty much. If the verifier flags a potential issue, then the router agent steps in. Its job is simple. Classify the error.
How does it classify them?
It decides if the flagged fact is not included in the references, meaning the AI just made something up that isn't in the source material at all, or if it's not supported, meaning the fact actually contradicts what's in the references.
Okay, so made up versus contradictory.
Right. And based on that classification, the router calls one of 5 specialized solver agents.
5 solvers. Okay, let's hear about them.
There's the era conflict solver. This one actually uses Python code to convert historical era names into Gregorian calendar dates to check for chronological problems, like did event A really happen before event B?
Clever. Using a bit of code for deterministic checks.
Yeah. Then there's the ref conflict solver. This one is interesting. If the reference documents themselves contain conflicting information.
Which can happen in historical records.
Definitely. This solver can actually flag it for human expert intervention to resolve the discrepancy.
So keeping the human in the loop for the really tricky stuff.
Exactly. Then the knowledge lack solver. If the AI seems to be missing some background context, maybe about the imperial examination system or ancient geography, this solver can actually go out and retrieve relevant information from external sources like the web to feed back to the LLM.
So it can fill knowledge gaps on the fly.
Kinda, yeah, to help the LLM generate more accurate statements. Then there's the alias conflict solver, which makes sure all the known correct names and aliases for a figure are presented properly.
Handles naming variations.
Right. And finally, a general solver for others. If the error doesn't fit into the other categories, this solver just prompts the LLM with a specific error message describing the mistake, hoping the LLM can self-correct.
That's a really sophisticated layered system for catching and correcting errors during generation. It's not just post-hoc checking.
Exactly. It's happening in near real time. They tested all this using the Jinshi dataset. Contains info on 173 historical figures, lots of ancient Chinese text.
And they compared it against some strong baselines.
Yeah, models like Memlong T5 Large, Quen 2.572b, some pretty capable LLMs, plus other RAG systems like GraphRag, and some named entity recognition baselines too.
And the results, you said they were impressive earlier.
They really were. Astorian consistently came out on top, not just in the overall quality of the text, measured by Rouge scores, which compare the AI text to human-written examples.
Right, standard metric.
But crucially, in factual accuracy. That 47.6% reduction in hallucinations and the 3.8x decrease in average factual errors per biography, that's a big deal.
Huge difference in trustworthiness, basically.
Absolutely. And their specific KG-based R component, it showed like a 50% improvement in precision and 21% in recall for finding the right information compared to the previous state-of-the-art.
So the retrieval part itself was much better, too. Did they do ablation studies, like taking parts out to see what happens?
They did. Those are always important. They found the multi-agent system was particularly effective at slashing those hallucination rates. Interestingly, they noted it could slightly lower the Rouge scores, maybe impacting perceived creativity or fluency a bit.
A potential trade-off there. Accuracy versus maybe strict adherence to the reference style?
Possibly. And the style PO component, the style tuning, that significantly improved the Rouge scores and further reduced the factual errors. So that part seems like a clear win-win.
Okay, what about efficiency? All these agents running. Does it take forever?
Well, they looked at that too. The initial offline training for Astorian took longer, mostly because of that style PO step. But the researchers argue, pretty convincingly I think, that the big performance gains justify that upfront time investment.
Fair enough. What about building the index or generating online?
Building the knowledge graph index was actually considerably faster for Astorian compared to other graph-based methods like GraphRag, and way faster than NER baselines. Embedding-based RAG was faster to index, but its retrieval quality was worse.
Okay, so index building is efficient. Online retrieval.
Millisecond level, significantly faster than the baselines they compared against.
Wow. So retrieval is fast, but the generation itself.
Right.
With all the agents checking.
That does take longer online, but again, it's presented as a deliberate trade-off. You accept longer generation time in exchange for much higher accuracy and fewer hallucinations, which, for historical biographies, seems like the right priority.
Absolutely. Accuracy is paramount there. Okay, stepping back a bit, let's think about the broader context in ML research.
Right. We've seen huge strides in abstractive summarization, and LLMs are amazing text generators. But this factual accuracy, this stylistic control, especially for specialized fields like history, that's been a persistent headache.
The hallucination problem.
Exactly. And Astorian feels like a really significant step towards tackling that problem, which has been a major barrier for using LLMs in these kinds of knowledge-intensive, high-stakes domains.
We've seen earlier attempts, right? Trying to bake knowledge into generation, maybe using knowledge graph embeddings or things like that.
Yeah, but Astorian's KG-powered RAD feels more direct, maybe more transparent. You can trace the facts back to the source chunks via the graph. And their focus on style connects to that whole field of controllable text generation, trying to get AIs to write not just fluently, but appropriately for the context.
So boiling it down, the real innovation seems to be the synergy, right? The combination of these different parts.
I think so. It's the KGRA getting the accurate information, plus the multi-agent system acting as this continuous real-time fact checker, plus the style-focused fine-tuning. They all work together.
And that clever in-context learning for chunking historical texts, leveraging their inherent structure without needing tons of labeled data.
That's neat. Yeah, and the two-step fine-tuning seems like an effective way to handle both facts and style with maybe limited expert data. The experimental results really back up that this combined approach works, and works well.
So thinking about real-world impact, this could be huge, couldn't it?
Potentially, yeah. Imagine historians having an AI assistant that can reliably synthesize accurate biographies from vast archives. That frees them up for the higher level stuff, interpretation and analysis.
It could also lead to more accessible historical resources, maybe for education or just for the public trying to learn about the past. More comprehensive, maybe easier to navigate.
And the principles here: accuracy, domain-specific style, fact-checking. They could definitely apply elsewhere. Think about summarizing legal documents accurately or reviewing scientific literature. Anywhere that getting the facts right and sounding appropriate is critical.
Of course, there are ethical considerations too, right? AI generating historical narratives.
Yeah.
We still need human oversight, careful consideration of bias.
Absolutely, that's crucial. But it's exciting progress in making AI genuinely useful for complex, knowledge-rich tasks. And Huawei's partnership with museums suggests they're already thinking about practical applications.
Okay, this brings us to our novel notions segment. This is where we like to brainstorm a bit, think about where research like this could go next. Purely speculative, of course.
All right, let's speculate. Idea 1. What about dynamic knowledge graph evolution and maybe more advanced multi-agent collaboration for updating biographies?
Ooh, so a historian wouldn't just generate a biography once, but could, like, monitor new historical findings or changing interpretations over time.
Exactly. You could build on their KG construction methods, right? Allow it to dynamically add or modify nodes and edges as new information comes in.
But how would you ensure the reliability of that new info?
Good point. Maybe enhance the multi-agent system, add a, let's call it a consensus agent. Its job would be to evaluate the credibility of new information from different sources, maybe using techniques from fact-checking research, and figure out how to resolve conflicts between new data and what's already in the graph.
The obvious benefit is an AI historian that stays current, reflecting the latest scholarship.
Right, but maybe less obviously. As the KG evolves and the agents are constantly analyzing this updated info, could they potentially spot connections or patterns in the historical data that we hadn't noticed before, emerging insights from the evolving graph?
That's intriguing. The real-world impact could be this living, self-correcting historical knowledge base, dynamic, accessible.
The big challenge, though, would be managing conflicting historical interpretations. How do you stop the AI from just reinforcing the most common view, potentially marginalizing other valid perspectives? Bias management would be key.
So, probability. Technical feasibility of dynamic updates seems high, building on existing work. But achieving truly nuanced, unbiased updates with conflicting sources, maybe medium probability, requires sophisticated conflict resolution.
Agreed. Okay, novel notion number 2, exploring counterfactual history generation with a historian.
What if history? Like tasking a historian to generate a biography based on a scenario where a historical figure made a different choice at a key moment.
Exactly. Could be a fascinating tool for exploring causality, the impact of individual choices. You'd need to extend the KG somehow, maybe with hypothetical nodes and relationships representing these alternative paths.
And modify the generation process so it follows the real history up to a point, then incorporates constraints or pivot points to go down the counterfactual path while still trying to maintain stylistic consistency.
Yeah, something like that. The obvious use is investigating cause and effect in history in a new way.
But maybe a less obvious benefit. Could comparing the actual history with plausible counterfactuals reveal underlying patterns, like principles of historical development or how resilient societies are to change? It might connect to research in causal inference, maybe generative models for structured data.
The potential impact. New perspectives for historians may be a more engaging way to teach history. Explore what might have happened if.
But the risk of misuse is definitely there, isn't it? Generating misleading or even propagandistic alternative histories. That needs serious consideration.
Absolutely. Responsible implementation would be paramount.
Probability-wise. Modifying the KG and generation logic for counterfactuals seems medium difficulty technically, but generating truly insightful and historically plausible counterfactuals without a lot of human guidance and validation, I'd say that's probably low probability right now. It's really hard.
Agreed. And it's worth repeating, these novel nations are just us thinking aloud, exploring potential futures inspired by this really interesting paper, purely speculative fun.
Okay, so let's recap. A historian really does seem to represent a significant advance in AI-powered historical biography generation.
Yeah, by cleverly combining that knowledge graph, or RAG, for accurate info retrieval with the multi-agent system for real-time fact-checking and style adaptation, it tackles the core challenges, accuracy and style, really effectively.
The potential impact on historical research, how we access history, how we understand it, it feels considerable.
Definitely. And if you're interested in the nitty-gritty, we absolutely encourage you to check out the original paper. We'll link it. It dives much deeper into the technical details.
And maybe a final thought to leave you with. As AI systems like historians get better at handling historical narratives, what new questions does that raise about how we even define historical truth? And what remains the unique, essential role of human interpretation in understanding the past?
Good question to ponder.
Thanks for joining us for this deep dive into A Historian.